All right, so we're gonna look into the thermodynamic consideration of the Diels-Alder reaction, if this reaction is spontaneous or not. At the end of this video, you should be able to say, hey, this is spontaneous and here's the reason why, or this is not spontaneous and here's the reason why. You should be able to explain it, okay? I'm gonna go kind of in short right here. So most reaction or the more spontaneous process usually go from an organized system to unorganized system. Okay, imagine like when you're starting from at the beginning of the semester, your room is like your dorm room, your apartment is real tidy and clean. At the final week, well, closets everywhere. So that's because like in order or unorganized is very comfortable. Okay, so the spontaneous reaction, for example, the combustion reaction. So we have charcoal and we burn it, right? And it just become water, carbon dioxide, and go to the air, right? That is spontaneous reaction. So from one molecules go to multiple molecules. But a Diels-Alder reaction is a reverse of that. We have multiple starting materials and put them together in one molecule. This is not, usually this is not spontaneous. All right. The delta S entropy, change of entropy is negative. Not really good. We usually prefer positive entropy. Okay. All right. So start from less order or become more ordered, become more organized. Okay. So the entropy term is negative. This is what happened. If you remember, the spontaneous reaction have a delta G gives free energy is negative. Let's see if the whole thing is negative or not. Now we know that delta S term right here is negative. So the whole negative T delta S term would be positive. Okay, this is a positive term. Now, this is not so good with a delta G. We want delta G to be negative, right? Now, let's take a look at the enthalpy, which is heat of reaction. Well, the Diels-Alder reaction has a driving force, if you remember, go from 3 pi bonds to 2 sigma bond and 1 pi bond. The 2 sigma bond is more stable, so this reaction actually releases heat. So delta H is actually negative exothermic reaction. Now, if you look at right here, so delta H is negative. The second term, negative T delta S, is positive. Well, whether or not delta G is negative depends on the competition between the two terms. Okay, so if you want to make this Diels-Alder reaction spontaneous, you need to make the second term, the negative T delta S, low. Okay, we have to keep this term low. How to do that? Well, we use lower temperature. Okay, and when I say lower temperature, the temperature is so relative. The temperature for one reaction could be like 25 degrees, and other reaction could be 1,000 degrees, right? For Diels-Alder reaction, the low temperature is about 200 degrees or lower, but can't make it too low. Let's say at room temperature, the reaction doesn't go or takes weeks to do it. Okay, so most Diels-Alder reaction will be run in about, let's say, 180, 200, 210, about that, or maybe higher for some reaction. It depends. But we try to keep the second term low, basically. So delta H will be dominant, and delta G will be negative. Okay, so is the Diels-Alder reaction spontaneous? Well, it's a little bit complicated. So you have to look at the competition between enthalpy term and the entropy term. Okay, and to make the second term low, we're gonna keep the temperature low, and the lower of this Diels-Alder reaction is about 200 degrees or lower. All right. Now I'm gonna ask you this: what if we run the Diels-Alder reaction and we increase the temperature, let's say 300 degrees, 400 degrees, 500 degrees? What's gonna happen? Well, this reaction is going to be non-spontaneous, of course, because the second term is going to be too large and dominate the enthalpy term, right? The whole thing is going to be positive. Well, but you do that when you want to break down the product of the Diels-Alder reaction. When you increase the temperature, so high temperature, so delta H still negative, right? But delta S still negative, but the whole term is going to be positive, just like we talked earlier. Now, if we increase the temperature, the second term will dominate and delta G is going to be positive, which means that this reaction will favor the formation of the starting material, the reactant. Okay, so my point is you can control the Diels-Alder reaction by controlling the temperature. If you want a reaction to go forward, use low temperature. right? And low for Diels-Alder reaction is about 200 degrees or lower. But if you want this reaction to go backward to favor the formation of the reactant, we call retro Diels-Alder reaction. So go backward, we increase the temperature. Okay, all right, that's the thermodynamic consideration. Now we're going to look at the component of Diels-Alder reaction. Start with the dienophiles on the next video. All right.